this is Mr. Manley. This is the second video in a three-part series on transformations. In the first part, we looked at shifting, vertical and horizontal shift. In this video, we are going to look at reflection, and then we will have a third video for non-rigid transformations. Referring to the previous video, we were working with parent functions. We were looking with the parent functions f of x equals x squared and f of x equals absolute value of x. We're not going to be working with these parent functions in this video. We're going to be working with some random undefined function. So I want to talk what that does with our notation if we're working with a random undefined function. For instance, if instead of, now remember with f of x equals x squared, we talked about f of x equals x squared plus c as a transformation that was vertical, up or down. Well, what if I didn't know the parent function? What if I didn't know about the x, that it was x squared? Then I would just refer to it as f of x is all I would be able to say about it. I wouldn't have an algebraic expression for it. So I'd just be saying, well, I've got some f of x, and then I want to talk about shifting that vertically, and the way that I would talk about shifting that vertically is I would go plus c. So even if we don't know what the parent function is, we can talk about the transformation of the function in terms of its name, which is typically f of x, maybe g of x. So in this case, that's what we have. We have a function here, an undefined function, some random set of points that defines the function f of x. And we want to do a transformation of that, namely a reflection, a transformation that is a reflection. So just like for the vertical translation or the vertical transformation, we have this notation, f of x plus c means vertical transformation. For this one, I'm going to have a notation which is negative f of x, and what that means, the negative f of x means a reflection through the x-axis. So think about that. If you looked at this random function f of x, and I said, I want you to draw negative f of x, and that is a reflection through the x-axis, would you be able to do that? So you can think in your mind about what that might look like, and I'm going to show you, first of all, I'm just going to show you graphically what it looks like, and then talk about the specifics of it. So graphically, what do we have? We have the x-axis here. So there's the x-axis, and I want to reflect this graph through the x-axis. And here's what that looks like. Just kind of freehand drawing and not worrying about the specifics of it. That's what it is. That's the reflection through the x-axis. Now we want to be more specific here. And I could just go based upon doing it graphically. I also want to look at it numerically. So graphically, what I need to just pay attention to is that if this is 4 units below the x-axis, I need to make sure that I'm 4 units above the x-axis, which it seems that I have. That the end point there looks good. All right. And then moving here to the middle point, if this is 1 point below, this point needs to be 1 point above, which again, it looks like it is. So I'll just anchor that point there. And then finally, if this point over here is 5 points below, then this point over here needs to be 5 points above. So I'm a little bit off with that, right? So I'm going to just clean that up and get this point over here 5 points above the x-axis, and then connect the line to that. All right, so just a couple of things I want to consider here. One is maybe you're not great at drawing, and you need some assistance, and we can do that with the points. So if you're not great at seeing this visually or translating it, you can just take the specific points. So this point here is at 7 and -4. So I need to be sure that this point in the reflection is at 7 +4. And then this point here in the middle point is at 4 -1. So I need to make sure that my reflection point is at 4 +1. And when I have this point on the left at -4 and -5, I need to be sure that its reflection point, the reflected point, is at -4, 5. So there it is numerically. And how could we refer to that? With a reflection through the x-axis, we could say that we have the same x value and an opposite y value. So we've got some definitions there. Again, you can do it visually, but make sure that you're precise on the reflection. And if you need to, you can look at the numeric values and follow this process of the same x value, opposite y value, and then connect your points accordingly. All right, in this case, so on the previous case, we're starting with f of x, and then f of -x, or negative f of x, I should say, is a reflection through the x-axis. So that was a x-axis reflection. And now we have, we're going to look at f of -x. And I think just intuitively, you could say, well, if negative f of x is a reflection on the x-axis or through the x-axis, then f of -x is a y-axis reflection. So that's what this is asking for. F of -x is saying, given this random undefined function here, reflect it through the y-axis. That's what f of -x means. And again, we could just kind of do it visually here pretty quickly like that. And actually I think I hit the points pretty well. And again, similarly to the reflection through the x-axis, I have to make sure if I'm 4 to the left here, I have to be 4 to the right there. And if I am 4 to the left here, I have to be 4 to the right there. So that's the reflection through the y-axis. And again, if we needed to, we could look at the specific points and say if I have this point here at 4, 5, then I have to have a reflected point at -4, 5. And then if we think about how I defined that in words here with the same x value, opposite y value, and we're just going to switch that for the y-axis reflection. We're going to say same, we're going to have, with a y-axis reflection, we're going to have same y value and opposite x value. And that will get us our y-axis reflection. With that, we have covered the shift, the transformation that is a shift. We have covered the transformation that is a reflection. And in our third part of the series, in the next video, we will look at non-rigid transformations.